So SDN and NFV are really two megatrends rolled into one, and what it's all about is greater innovation in networking. That's the stuff that glues together all the components of the internet. Basically the picture was before, it's a pretty slow-moving scene where we make big metal pieces of equipment for networking, and the idea of SDN is to pull apart that equipment and separate out controlling networking from doing the networking, whereas NFV is about using virtualization, which is used in a lot of other contexts, in order to share hardware so you don't have 10 separate boxes for different networking functions. This megatrend is pretty far-reaching because it's allowing networking to catch up with all the innovation that's been happening in things, like smartphones and computer equipment and the Internet of Things, which is a new term where everything, including your home devices like your fridge and things, will be connected together in your car. And really this is about doing the infrastructure that underpins all of these smart devices that people want to use. And really it's allowing networking to catch up with the world of the app. There's been a lot of innovation in apps, as people know, in smartphones, and this is really providing the networking that can scale with the different apps and provide new services quickly to the apps that they need. The fundamental technologies behind this mega trend are really twofold. One's hardware and one's software. On the hardware side, we've got very fast wireless networking, which allows you mobility to your smart devices, and the other is optical networking, which is a background infrastructure that connects things together. And on the software side, it's a move towards open software and communities who are building open software, so that's much more shareable, plus the trend of virtualization, where one piece of equipment can do different functions over time rather than just doing one thing for all time. Xilinx technology is very important for this megatrend for two reasons. One is, as in the software defined and the functions of virtualization, it's all about programmability. You want to be able to change things, reprogram it. But the other aspect is performance. For the world of wireless and optical, as I mentioned, data rates are getting faster and faster, and response times to people need to be shorter and shorter. So what we need is a combination of both programmability and performance. And for that, the Xilinx FPGA is perfect because it gives you both of these aspects. But the thing we need to make sure we do is provide the programmability in a way that software people can use it easily, and that's where the Xilinx SD environments come in. We're providing something that isn't a hardware design experience, but more like a software design experience, but then delivers hardware performance. So that's a perfect sweet spot, and why we think Xilinx can take the lead in SDN and NFV.